we go. Exercise 3D. So remember, I told you I wanted you to look at 3A, B, and C because that's revision from last year. It would have been an intro into transformation. So for those who struggled last year in year 11 with transformations, things like translation, I think that's usually 3A. And then 3B could be reflection or dilation. It's one of them. And then maybe 3C is reflection. Or it might be the other way around. But the idea is that's your revision from last year. D, I'm doing it again, but it's nice because it combines translation, dilation, reflection. What do you take out of chapter 3 if we're talking about essence again? So remember, chapter 1 was E and F. 1E, 1F was your core. Then the core for chapter 3 is 3D and 3E. 3D essentially looks at, can you find the transformation equation from a sequence? 3E is the reverse. Can you work out the sequence from a transformation equation? Okay, so it's just going back and forth. That's why D and E are sort of back to back. You learn how to follow a sequence first, get the transformation equation, and then in the next exercise, going backwards, using a transformation equation, going backwards and say, what's the sequence? Okay? So today I'm just going to focus on D, and the next lesson, which do I have you next lesson? Yes, I have one more. Next lesson, we'll then do 3E, 3F together, because that pretty much finishes off the chapter 3 that you can go both either way, and then you can apply it to sketch. That's what chapter 3 is all about. Yeah? All right, here we go. Let's do an example to revise transformations again. So we're trying to follow the sequence. We've got find the rule of the image, which means tell me the equation, the new equation. If your new or old equation, your current equation is y equals x to the power of negative 2, which is a truncus function. They want you to take this truncus function and apply these transformations in the current sequence. So they want you to do a reflection of the x-axis first, then followed by a translation of 3 units to the right, then translation of 4 units down. So what equation do I have? What do I write to this new truncus function to demonstrate that? Okay, that's what they're saying. So that's what 3D is. So how do we do it? Well, first, you need to be able to read these transformations as a mapping notation. Okay, so hopefully you've either remembered from last year revise ABC, or you've watched my videos on ABC, but here we go. Reflection of the x-axis. What does that look like as a mapping notation? Let's go with, yes, Sima. Reflection in the x-axis. Ooh, close. In the y. And one way to kind of remember it, as I was trying to picture it as well, when I say reflection of the x-axis, it's a mirror here. So that means if you have a dot, say there, reflection of the x-axis means it's going to flip symmetrically up. There's going to be a dot over here if the mirror's over here. So hence, if you flip up, what's getting affected is not the x value. The x value stays the same. It's the y value. So y1 now becomes the reflection of that. It's a flip. So that's why it's a negative. Okay, vice versa. For positive become negative or negative becomes positive. So that's why we know it's a negative, which Samar was correct. But being careful, that is not negative on the x. And it's easy to confuse because it says x-axis, and then we put negative on the x as well. But just think of it pictorially or visually. All right, so we got the first one. Well done. We've got negative y. So we went from original xy coordinates, and we know that we're going to put a negative on the original y. So flip it over the x-axis. Next one. Translation of 3 units to the right. So I'm shifting the graph to the right by 3. How do I do that? Let's go with Anne. Translation 3 units to the right. What's the mapping notation? X plus 3, very good. So horizontal movement is to do with the x coordinates. So it's all to do with the first section. And to move to the right, well, you're adding every coordinates by 3. So yes, it is x plus 3. Well done. And then lastly, we have translation of 4 units down. Krish. Very good. So then we say minus 4. Okay, so we're going down by 4. So this is our sequence, our transformation. Okay, so it says reflection, translation is the same, so it doesn't matter whether it's x plus 3 or minus 4, would have been the same anyway. Whether you go down 4 and then right by 3 or right by 3 and down 4, you end up in the same spot. So let's work out, well, how do you work out the new equation? So last year you would have learnt what we call mapping notation. And the way I explained it to my class last year is I said, this is your original x and original y. Okay, so this is your original x, original y. So they have to tell you what function you're starting off with and where do you want to get to. So the new x and new y, which is this one, this is the new x and the new y coordinate because I'm mapping old x, old y, and I want to get to the new one. So how do I get to new x? I add the old x by 3. So whatever this was, I added by 3, gives me a new x. Whatever my old y was, I'm going to times by -1 and then subtract 4. That gives me my new y. So if you actually write that out, literally as an equation, there's a relationship between new x and old x. That's my relationship. To get to new x will equal to old x plus 3. To get to new y, the result of new y is the result of negative y minus 4. What's your goal? Your goal is to find out the new equation. Right now, this is in terms of old x and old y. So if you can rewrite this equation with a new x and a new y in there, or x dash y dash, then you got yourself a new equation. So you need to replace this. You need to replace the y, and you need to replace the x. But to replace that, you need an equation in terms, or not in terms of, you need to make x, the old x the subject, and the old y the subject. So here, I can rearrange it now. So here we go. Old x is here. I need to remove the plus 3. Minus 3 on both sides. And I get old x is equivalent to new x, take away 3. There's my relationship. Same thing with this one. Add 4 on both sides. And then divide both sides by negative. That's my y transformation. I'll talk about what you do at this point here and what you need to be careful of when it comes to the exams. So I'll just leave it in this format for now, and then I'll explain what happens for you to be a bit more flexible. So now I've got old x, I've got old y. So we can replace them now. We can say instead of y, old y, I can replace that with negative of y dash plus 4. So this side now becomes negative of y dash plus 4 as my new equation. 1 over, here's my x. I'm replacing that x with x dash minus 3. So here we go. Don't forget the square, because the square has always been there. I'm just replacing the x and the y. Then suddenly, this is now the new equation. I've got new y, I've got new x, but the way we normally write our functions is y is the subject. So, here we go. Expand the brackets, or you can divide both sides by a negative. And this is where, because it's a transformation equation, it doesn't matter. In 3e, it does matter whether you expand that bracket or not. Okay, so when you're doing the sequence of transformations, I usually say follow Dr. T. But I'll explain why sometimes that doesn't always happen in your exams. Okay, but for now, from here we do expand. We can say, all right, let's divide both sides by negative. So then you get y dash plus 4 is equal to negative 1 of x dash minus 3 all squared. So all I did was just times both sides by negative 1. That now is positive. That one's a negative. And I just need y dash by itself. So I'm going to subtract 4 on both sides. So y dash is equal to now negative 1 over x dash minus 3 all squared minus 4. So I have gone from this original equation to the new equation. Old x, old y, new x, new y. And how do you know they're new? I put a dash on it. And that's what I was saying over here. That's new x, that's new y. That's the relationship. This is called mapping notation. Do you have to do mapping notation? No. Chapter 3 is a technique for you to identify exactly what it is. After a while, some of you actually already can write out the equation without doing the mapping notation. Fair call, nothing wrong. I just know the examiners also know that. Most students can do the basic ones like translations and sometimes reflections, but dilation is the common one, especially when they do dilation or translation before dilation. They will purposely make it so that if you just did it intuitively, there might be a slight factor difference. You might get it wrong on just a factor point. So when it gets a bit tricky, I do recommend using a mapping notation to double check. But if you're highly confident, you can probably go from this step to this step, and that's the expectation, okay, that you just get the answer. So they don't give you marks for doing this. Doesn't matter if you do mapping notation, they don't care. They just care if you get the right answer, okay? But it's a tool to get you there. It's kind of like back in year 7 using a number line to work out negative numbers. You don't have to do a number line, but it helps you to get there. Once you get really good at it, you don't need a number line to add negative numbers. Yeah, so same thing with mapping notation. You technically don't need it, but it's good practice if you didn't master it last year. Okay? All right, so that was the first example, and just one more example, and that's it for today. And you have the rest of the session to yourselves. Here we go. If you're ready, again, if I'm going too fast, the notes are on OneNote. You can always go back and have a look or watch my video again. But let's go 3, 2, 1, flip over. All right, so this one, slightly different. This one now asks you to sketch. Okay, so we're going to find the new equation and we're going to sketch it. All right, so here we go. Sketch the graph of. Now let's see how many of you remember the concept of exercise 1G. X to the power of a third. What does this roughly look like? What does this look like? Ah, I just realized I already have it for you. Well, it looks like an S. But actually, I didn't realize I printed it for you just in case you didn't know. But yes, it's the inverse of a cubic. So if you think about a cubic, it looks like an N. And the inverse, if you tilt your head, draw a symmetrical shape, looks like an S. Okay, so this is a cubic, like that. So if you draw this line, if I drew it properly, then it should look symmetrical. Okay, so it looks like an S. Great. Here we go. This is our sequence of transformation. Let's pick out a couple other people. Reflection in the y-axis. What's the mapping notation to this? Let's go with Adonis. Reflection in the y. Negative x. Very good. So we've got a negative x. Reflection done. Next one. Translation of 1 unit to the right. Let's go with Erwin. Me? Or the class? Oh, do you guys? I thought you guys just go down. All right. Well, thank you. Let's pause the video and let's go put on our smiles, shall we? And let's continue. So we left off at translation of 1 unit to the right and 2 units down. So I'm just going to fill that one out. So unit to the right plus 1 to the x, and then y take away 2 down. So that makes sense. Now the last one is the interesting one. Dilation of factor half from the y-axis. Who wants to have a go with this one? Or anyone remember? Where does this one go? Is it 2 or is it half? It's half, and it's going to x or y. Very good. I was obviously trying to test you guys there. Yes, half factor from y. How do you know that word from? That's a key. I think of it as, because dilation is a stretch, you can think of it as like, I can stretch it horizontally, or I can stretch it vertically. So I can make the graph really thin vertically, or it can be really thin horizontally. But when they say moving factor of half from y-axis, so you think about where the y-axis is. So essentially, I'm stretching away from. See, from, I'm moving away. So from. So if you move your hands in that direction, you can kind of see, well, it's a horizontal stretch. If it's a horizontal stretch, then I'm clearly affecting my x values, because this is to do with the horizontal transformation. So, yes, you're right, it is half, and because of that, and based on the sequence and the order, technically, you should put a half at the front, like that, in brackets, okay? Because it was reflection, then translation, and then now dilation. So that means that half times the negative x, don't forget this plus 1 as well. Because if you don't do that, you'll get the first term, but you'll miss out on the second term. Okay, because it's halving that transformation you did initially. So overall, technically, you're moving to the right by half at the end of the day. All right, so how do you find the equation? Same thing. Does it ask for the equation? No, it doesn't. But if you were to find the equation, this is x dash, this is y dash. Here we go, we do it again. X dash is equal to half times negative x plus 1. Rearrange it, so you get 2x dash is equal to negative x plus 1. And original x will equal to negative 2x dash plus 1. Is that right? Sure. No, wait. Minus, yeah, plus 1. Good. So that is my new equation for x. And then same thing, y dash is equal to y minus 2. Therefore, y dash plus 2 equals to original y. So what's my new equation? There you go. I started off with y equals x to the power of a third. Replace the original x and replace the original y. And if you do that, replace the original y, replace the original x, you should get the new equation as y dash plus 2 is equal to negative 2x dash plus 1 to the power of a third. Notice that if you quickly read this one, oh sorry, I should move that plus 2 across as well. So negative 2x dash plus 1 to the power of a third minus 2. If you read the transformation, it's still there. It's down by 2, which we had. This one technically is to the right by half. And it makes sense because you moved to the right by 1, but then you halved it. So naturally it then gets shortened by, because of the dilation, compression, it becomes half. Okay? So what does this look like if I asked you to sketch it? Here we go. You started off at the center of 0, 0. You're going to go down by 2 because it says down by 2. And I know it says 1 to the right, but remember, you're doing a dilation of a factor half. So it ends up actually being only half to the right. And you can tell by reading it from this step here. If you expand the brackets, half times negative x and then half times the 1, you can see that change. So if you multiplied here, you then would see it's actually negative half x and then plus half. So I know it's moving to the right by half, but you can also read it from here too. Okay, so this is exercise 3E, reading the transformation equation to find out the sequence. That's the skill. So I know that's technically one half to the right, down by 2. It's not to scale, by the way. I'm just drawing it so you can kind of see. So center now should be at half negative 2. And we also know there's a reflection. It said there's a reflection in the y-axis. So if it's in the y-axis, it should have flipped the other direction. So instead of it looking like this, it should be the other way around. Okay. And what else do we have? That's about it. So you just shift it down. Looks like a reverse S in that direction. Okay, obviously I haven't worked out my x-intercept and y-intercept, so I can't draw it accurately. But this is what it looks like on Desmos. You can see the center line, half. It's about the halfway point, and it's down by minus 2. So not to the right by 1, but it was to the right by half because of that dilation. Here's your reflection. There you go. So this is exercise 3D. What do you take out of it? 2 skills. So skill base is a revision of last year. Can you find out the transformation equation, which is using mapping notation? Optional. Sketching is what 3F is. Okay, so the ability to just look at an equation, read the sequence, sketch the graph, that's what you want to get to. So core exercises for you, 3D, 3E. But I'll do 3E next session, 3E and F next session. Practice mapping notation if transformation was not as good last year or you need a bit of a refresher. I'm going to stop the video there.